we'll proceed further. Now let us discuss RF energy harvesting. So for RF energy to be harvested, you should know what is the energy that is available right now. So what are the energy availables? If you look at the power spectra of the Indian microwave power spectrum or the global power spectrum, you would find 4 to 5 main buckets of RF energy available. The first one is around the 500 megahertz band, which is for digital TV broadcasting. Next one is the 800 to 900 GSM band. The other one is the 1800 to 1900 GSM band. Next comes the 2.1 to 2.2 3G system. And finally, the 2.4 gigahertz Wi-Fi system. So these are all the sources that you're looking at. And if you need to harvest, the best way to do it is stay close to some of these cellular phone stations and radiating sources, which are your transmitting stations, and your wireless routers, RFID readers, mobile phones, and RF radios are all your receiving stations. So you will typically be using these receiver blocks or receiver look-like circuit elements to absorb this energy and then convert them to usable electrical energy. Now, before we go that, the first thing you need to really understand is a very old equation which gives an understanding. This was typically developed for radars to find out what is the received power from a radar and what is the expected transmitter power to find out what is the range in which the radar can operate. But a similar application or analogy, if you use it, can be used for your wireless routers and mobile phone receivers. On the left hand side, you will see there is a transmitter and a receiver separated by a distance dr. The power transmitted is PTX and the power received is PRX. And the gain factor of the TX and the RX receivers are given as GTX and GRX. So the FRIIS equation or the FRIIS formula for the received power at the receiving antenna is given as a product of the transmitted power multiplied by the gain factor of the received transmitter over the 4 pi r, or what you could say the spherical presence of the radius of, or the distance between the two subjects or the two objects. So here r shows the distance between the antenna, and this is actually the squared. The reason it is squared is the power depreciates or the power falls down significantly because the air in the system absorbs some of it or it dissipates a lot of it into that. And this is directly dependent on what is the frequency of the system. So 4 pi r by lambda whole square is the actual equation which looks at what is the impact. So the amount of power dissipated is directly dependent on the lambda. So when the lambda increases, frequency falls. That means as the frequency increases, the rate of falling of power follows faster. That is why you look at, you can receive FM stations within a city. You can receive your Bluetooth radio within say 10 meters, but your shortwave radios you can even hear from Russia. So people who have a habit of listening to shortwave radios, you can still receive to some of the farthest stations. And even the AM radios can go all the way up to Ceylon and Burma, or which are called Sri Lanka and Myanmar currently. So these are some of the age-old communication system concepts that we will utilize while doing energy harvesting.